Okay, and problem set 4 is where we really get into the algebra. And it's really important that you have all the stuff from problem sets 2 and 3 down really well first. Let's start off with review. Circle the terms and simplify. First of all, remember what terms are? Terms are numbers being added, right? How many terms do you see? 2, right? I'm not going to circle them, but the negative 24 is a term and 11 is a term. There's 2 terms, right? So when you add, remember how to add integers with different signs? There's different ways to look at it. We were looking at on the previous problem set, but when they have different signs, you can forget about the sign for now and just take 24 minus 11, which is 13. And since the bigger one's negative, it'd be negative 13, right? Okay, how many terms do you see here? How many numbers are being added? There's 4. So you'd circle the negative 12, the 9, the negative 8, and the 11. That's right. Now, is it okay to add the negatives together even though they're not next to each other? Yeah, now what property is that called again? That's called the commutative law. You don't have to do it this way, but you could. If you add the negative 12 plus negative 8, you get negative 20. If you add the 9 plus 11, you get 20. So what's your final answer going to be? 0, right? Okay, so here we go. Remember we talked about how important the terminology is in this class, so make sure you understand what these words mean. It's crucial. In algebra, you use variables, which are letters that represent unknown numbers. So when you see a variable like x, you should be thinking that is a number. You just don't know what it is, but x stands for some unknown number. You can use lots of different letters for variables, but notice capital M used with a small m, those stand for different unknown numbers. So when you're using letters as variables in algebra, make sure you don't change the case of the variable. Keep it, if it's a capital M, keep it as a capital M. When you see something like this, 3x, that means 3 times x. We say 3x or 3 times x. X is an unknown number, so 3 times x is also an unknown number, isn't it? Here, x, y, and z are different unknown numbers. Let's put it this way, they don't have to be the same, so assume they're different. This is negative 5 times one unknown number times another unknown number times a third unknown number. So this whole thing here stands for an unknown number, doesn't it? Okay. Now, in algebra, like terms are terms. First of all, terms are numbers being added. Remember, x is a number, so when I say numbers being added, it could be a variable also. Like terms have exactly the same variables, and it turns out when you have like terms, you can add them together. You can combine them into one. I'll show you how it works. If you recall that 3 plus 5 is 8, then when you have something like this, these would be called like terms. They're terms because they're being added. They're like terms because they both just have an x in them. If this had an x and this had like a y, you couldn't add them together. But since they're like terms, it works the exact same way. And here's how you can think of it. You have 3 times an unknown number here, and you have 5 times the same unknown number here. So even though you don't know exactly how much you have, you know you have 8 of that unknown number. So if you understand how integer arithmetic works, algebra works the same way, as long as they're like terms. Okay? Are these terms? Yes. How many terms you see? 2. Are they like terms? No. So unfortunately, that's all. You can't do anything. You cannot combine unless they're like terms. You just leave it as 3x plus 5y. Are these like terms? Yeah. And it works the same way as with integer arithmetic. So if you can tell me what negative 4 plus 12 is, it's 8, isn't it? Then you can tell me what negative 4a plus 12a is. It works exactly the same as integer arithmetic, as long as they're like terms. Pretty fun, isn't it? Okay, let's keep on going here. Here we have an expression, negative 3x plus 5y plus 7x. How many terms do you see? 3. Are there any like terms? Well, the x's, this and this are like terms. You can add those together, but the 5y is not a like term. But you could add the negative 3x plus a 7x even though they're not next to each other. What law is that allows you to move numbers around, to commute the numbers? That's the commutative law, right? So you could add the negative 3x and the 7x and get 4x, positive 4x, and then just keep the 5y there and don't fall into the trap of adding these together. They're not like terms. Just leave it as 4x plus 5y. Okay, how about this one? By the way, you're more than welcome to hit the pause button and try these on your own. Don't wait for me. I will give you some to try in just a minute, but at any time during these videos, if you want to just try it on your own, that's a really good idea. Hit the pause button and see if you can do this one, if you want. Anyway, so but you should see there's 4 terms, and you should see that there are some like terms. The A's, these 2 are like terms, and so are the B's, right? So read it out. Negative 5a plus 2a, isn't that going to give you negative 3a? And 3b plus negative 9b, that gives you negative 6b. Can I combine these? No. How come? Not like terms. You see, there's reasons for everything. All right, more notation. You gotta get this stuff down. When you just see a term, or I should say a letter, when you just see a letter like X or A by itself, think of that as 1 times it. Think of it as being a 1 in front. Isn't that true? When you see 3, isn't that 1 times 3? So this should make sense. And when you see a negative in front of a variable or a number, that means negative 1 times that number. For example, negative 3, isn't that the same as negative 1 times 3? So although these 2 rules or these 2 statements might seem obvious, they're really important. For example, when you see something like this, it's crucial that you see this as 1 times x plus 5 times x. Think of it as 1 plus 5, which is 6, right? So there's a 1 in front of here. It helps, doesn't it? This one, what is negative 9m plus 8m? Well, if you can tell me what negative 9 plus 8 is, negative 9 plus 8 would be negative 1, so it's going to be negative 1m. We usually don't leave it like that. Usually you just leave it as negative m. So this is the answer, negative m. It's just a notational thing, isn't it? I will do a couple more, then I'll give you some to try. How about that? This one, how many terms you see? 4 terms. You see any like terms? Yeah, the x's and the y's. So say it out loud. Negative 3x plus 2x would be negative 1x, which we write as negative x, remember? Negative 1x means the same thing as negative x. 5y plus negative 4y would be 1y, which is just written as y. This is how we write it. All right, this is a good one. How many terms do you see? 3. Any like terms? Well, it turns out, see how it says 5xy and negative 7xy? These are like terms, because remember the definition? Like terms have exactly the same variables. This has an x and a y, this has an x and a y. So you can actually add 5xy and negative 7xy. It works the same as with integer arithmetic. 5 plus negative 7 is negative 2, so 5xy plus negative 7xy would be negative 2xy, you see? And then plus the 12x, you can't do anything because they're not like terms. All right, a couple more. This one, let's see. How many terms do you see? 3. Any like terms? No. If there's no like terms, you can't do anything. So don't fall into that trap and add them when they're not like terms. How many terms do you see here? 4. Any like terms? Remember, like terms have exactly the same variables. Well, this has a big M and a little m, this has a big M, this has a little m, this has a big M and little m. So these 2 are like terms. The first and the last are like terms. You add them just like integer arithmetic. Negative 3 plus negative 4 is negative 7. So negative 3mm plus negative 4mm is negative 7mm. And then you just have to leave it as plus 5m plus 2m. There you go. There's a name. This number in front of the variable is called the coefficient. So let me go back here for a second. The coefficient of this first term is 3. The coefficient of the second term is 12. The coefficient of the last term is negative 7. So that's the coefficient. It's the number in front of the variable. Well, what's the coefficient of this term? Negative 1, right? What's the coefficient of this term? 1. Very good. Excellent. I think you're getting this stuff. All right, let's see. Hit the pause button and try these on your own. Okay, let's go over these. The first one, how many terms you see? 2. Are they like terms? Yes. Remember, this is negative 1m. So what's 7m plus negative 1m? Why, it's 6m. How many terms do you see here? 2. Are they like terms? No. This is an n, this is an m. I know they're right next to each other in the alphabet, but that doesn't mean anything. They're not like terms. You just got to leave it as 7n plus negative m, okay? Just leave it like that. Here, how many terms do you see? 3. Any like terms? Yeah, the x's. So when you add the x's together, negative 5x plus 6x is 1x, which we just write as x, plus 3y. Just leave it like that. Here, how many terms do you see? 3. Any like terms? No. You gotta leave it like just negative 5x plus 3y plus 6. Here you see 4 terms. You can add the a's together. What is 5a plus negative 6a? It's negative 1a, which we just write as negative a. And what's 3b, and negative 3b plus 4b? It's 1b. So your answer would be negative a plus b. Here, these are like terms. Negative 5z plus 5z. We get 0z, which we just write as 0. Don't write as 0z. Although that's not wrong, it's just better to write as 0. How many terms do you see here? 3. Are there any like terms? Yes, they're all like terms, aren't they? So you can add them all. If you add the first two together, you get negative 9k, right? And then when you add negative 9k to 9k, you get 0k, or just 0. Last one. You see 4 terms. Any like terms? Remember, this is 1 times big Y little y. So 1 big Y little y plus negative 2 big Y little y would be negative 1 big Y little y. And then the other 2 terms are not like terms because they're different cases, right? This is negative 4 big Y plus 3 little y, and that's your final answer. Alright, that's our final answer. We're done. We'll see you next time. Bye-bye.